Today we talk about rational functions. If you remember from last year, rational functions are those which have these things called asymptotes. If we take a quick look at the graph, there's some boundary line, if you will, horizontal, vertical. Graphs look something like this. Okay. The ones we're going to do are going to start out looking similar to this and then get much more complicated. In each of these, we're going to look to do the following things. We're going to first find some intercepts, both x and y. Second, look for our vertical asymptotes, or what limits the domain. So we're going to set the denominator equal to 0 to find that. Third, we're going to find horizontal asymptotes, and we're going to see that horizontal asymptotes describe what is the end behavior. As x gets very, very large, what does y do? And like in this situation here, as x gets very, very large, negative, where does y go? And some key things for finding those horizontal asymptotes are looking at the degrees of the numerator and denominator. So if the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, you just divide the leading coefficients, and that will be the horizontal line of the asymptote. And if the degree of the numerator is 1 more than the degree of the denominator, you're not going to get a horizontal asymptote, but you're going to get something called a slant asymptote, and that will be in our next lesson. And we'd have to use long division to find that. Then we'll sketch our graph with all the information that we have, and we may be missing some points that are necessary, so we might have to plug some stuff in. Well, let's jump into it. So our first example is of the more basic type. The first thing we're going to do is we're going to find an x and a y-intercept. So x-intercept first. We know that to find an x-intercept, we set the y equal to 0. And now you'll notice that when I go to solve this, I multiply x plus 5 to both sides, and I get 0 equals 3. We know this isn't a true statement, so there is no x-intercept. To find the y-intercept, we're going to take and set x equal to 0. When we do that, we get 3 over 0 plus 5, which equals 3/5. A vertical asymptote, we're going to set our denominator equal to 0. So in this case, our denominator is x plus 5. Set that equal to 0. We get x equals -5. And we notice in this case, the degree of our numerator, degree means the greatest power of x. We have x to the 0 and x to the 1 in the denominator. And the rules we had before were if the degree of the numerator is less than the degree of the denominator, y equals 0 is our horizontal denominator, or horizontal asymptote. So now we're going to graph based on what we have. Again, we're just doing sketches. So I have no x-intercept, but on this x-axis, I will have a horizontal asymptote because y equals 0. So I'm going to put this dotted line here. Then we're going to take and graph our y-intercept. If this were 1, 3/5 would be somewhere around here. We're going to then graph our vertical asymptote of x equals -5. So here's 1, 2, 3, 4, 5. And I'll do that in black again. So here's the deal we have. We should be able to graph most of this right now. We may have to plug in a point. I'm going to take and state that, well, I know my graphs are going to approach my asymptotes. They will never cross a vertical asymptote because your domain's limited there. So I can go from this point and slowly approach this line, go up forever. Now we said horizontal asymptotes described in behavior. So as x gets very, very large positively, my y value is going to approach that horizontal asymptote of 0. Now here's the problem. I don't have any points on the left-hand side for this graph to go through. So what I'm going to have to do is check to see what kind of value I get to the left of this asymptote. So what I want to do is I want to find out what happens when the function's value is, let's say, -6. And that will help me graph the remaining part of my line. So I plug f equal or -6 into my x value. All I really care about is if I have a positive value and a negative value. So 3 is positive on top. When I plug a -6 into the denominator, I get a negative value. This leaves me with a negative. So at -6, I have some negative value for my y. Since this graph only has 0 x-intercepts, I know I will never cross over into the positive range. Therefore, my graph has to look like this. Let's move to the next example. Step it up a little bit. Okay, now in this example, once again, we're going to find our intercepts. X-intercept. We again set our y value equal to 0, and in this case, we're going to notice that we can actually solve this equation when we multiply by 2x minus 4 to both sides. We get 0 equals x, and that's our x-intercept. The y-intercept, once again, I'm going to set y equal to 0. I'm going to set x equal to 0, so I get 0 over 0 minus 4, which is 0. So we notice that our x and our y-intercept are at the same spot. Vertical asymptotes, set the denominator equal to 0, so 2x minus 4 equals 0. We get a vertical asymptote at x equals 2, and our horizontal asymptote, we're going to look at the degree of the numerator and denominator. And we notice that we have x to the first and 2x to the first as our degree terms. It says if my degrees match, which they do, 1 and 1, I take and divide the coefficients of the leading terms. So y equals 1/2 is my horizontal asymptote. Let's go sketch again. 0, 0, my x and y intercept. My vertical asymptote was x equals 2. Draw my little dotted line there. My horizontal asymptote was y is equal to 1/2, like so. I can now actually complete this entire graph, and I'll tell you why. I know that the graph has to go through the point 0, 0 and then approach the vertical asymptote. So this part looks like this. I know as x goes to infinity, both positive and negative, I'm approaching my horizontal asymptote. So this continues out to this line, but never really just approaches it. Now on the right-hand side, like the example before, I don't have any x-intercepts, so I know it's not going to cross this x-axis. Therefore, if it's not going to cross the x-axis, I know I'm not starting in the negative area and moving to the positive area, which means I must be always in the positive area. Therefore, my graph must exist in the upper right-hand corner. That's going to be a concept we use quite a bit, looking to see where our x-intercepts are and then making some assumption. It's not really an assumption, but making a statement based on that. Let's move to the next example. Okay, we've increased our degrees to 2, but as you'll notice, once again, these degrees match. So we should be finding our horizontal asymptotes fairly easily. Again, x-intercept, set y equal to 0. So we have 0 equals 3x squared over x squared minus 9. Once again, multiply by x squared minus 9 to both sides. We notice x equals 0. Y-intercept, once again, set x equal to 0. When we do that, we get 0 over 0 minus 9, which again is 0 for my y. Vertical asymptote, we're going to set our denominator equal to 0. And you'll notice in this case we have a factoring. So this is x plus 3, x minus 3, which gives us plus and minus 3 equals x for our vertical asymptote. So we actually have two vertical asymptotes. Horizontal asymptote, as I stated before, you notice our degrees match. I have squared and squared. Divide the coefficients of the leading terms. So 3 equals y is our horizontal asymptote. Let's go through and start sketching what we know. So I have an x and a y intercept of 0. Put that point at the origin. I have vertical asymptotes at 3 and negative 3. So I'm going to sketch those. And then I have a horizontal asymptote, again, which describes end behavior at positive 3. So now I'm going to start graphing this. Here's something I know. Once again, I look to see where my x-intercepts are. I only have one at the origin. There are no x-intercepts to the left of this asymptote or to the right of this asymptote. Therefore, I know the graph cannot start down and approach this horizontal asymptote without crossing the x-axis. So I can state that my graph has to be in this region here and this region here. This is the region in question. Now it would appear that we've got this asymptote right here, and in the vertical asymptotes we know we can't cross them. What I've never stated up to this point is you cannot cross a horizontal asymptote. Horizontal asymptotes, once again, only describe end behavior. What happens when x is ridiculously big in the positive and ridiculously big in the negative? So there's we don't talk about what's happening in the middle, and this is the middle. All right. So what I'm going to do is I'm going to pick a point to the right and to the left of this intercept to see what kind of values come out. And once again, I'm only concerned about whether I get a positive or negative value. So I'm going to pick 2 points. I'm going to pick f of 1, and I'm going to pick f of negative 1, and see what kind of values come out. When I pick f of 1, notice in the top I get 3, which is a positive number. In the bottom, I get negative 8, which is a negative number, and that divides to a negative value. So to the left, I get a negative value. Or I'm sorry, to the right, I get a negative value. To the left, we do the same thing. We plug in. I notice once again I get a positive on top. I'm going to get a negative again on bottom. It's giving me a negative overall. And to the left, we have a negative. Okay, let's move on. In this next example, we'll notice that the degree of the numerator is actually one more than, or one less than the degree of the denominator. So since it's less, top's got to be 1, bottom's got to be 2. That'll tell us something about our horizontal asymptote for my x-intercept. I notice when I set y equal to 0 and multiply by the denominator, I'm left with 0 equals x plus 7. So x equals -7 is my x-intercept. My y-intercept, by setting x equal to 0, is going to be equal to -7/5. Vertical asymptote, I notice the denominator factor, so that's going to be x plus 5, x minus 1. Therefore, -5 and 1 are going to be the lines of my vertical asymptotes. My horizontal asymptote, we have the rule that states when the degree of the numerator is less than the degree of the denominator, y equals 0 is my horizontal asymptote. So, sketch out a graph again. At x equals -7, I have an intercept over here. Let's call that -7. Y equals -7/5. It's a y-intercept of a horizontal asymptote on this x-axis. And you'll notice right here there's an oddity, if you will. We're going and having a point on that horizontal asymptote, which is okay because we said the horizontal asymptote only describes end behavior. My vertical asymptotes are 1. Call this 1. And -5. Once again, call that 1, -5 here. So now I should be able to draw a little bit of this graph out. I'm going to start with my point in the middle because I know the graph has to go through that. I also know it's not going to cross over into the positive region from here because I have no more x-intercepts. So I know my graph has to go down and approach that vertical asymptote and down and approach that vertical asymptote because once again it can't cross. Here are my next two regions, and I really know nothing about them other than it does go through this point, -7. However, I don't know if it starts above, crosses and comes down, or starts below, crosses and comes down again and approaches that line. So I'm going to have to do a couple of things. I actually need to plug in 3 points. I need to plug a point to the left and to the right of this point in to find out if it's above or below the axis, and then I need to plug a point to the right of 1 in. So I'm going to look at f of 2. I'm going to look at f of -6 and f of -8. All right, when I plug 2 into my function, I get a positive in the numerator. And notice in the denominator, I'm going to use this factored term to determine the value of my denominator, whether it's positive or negative. So when I plug in a 2, you'll notice I get a positive and a positive. Thus, the output of all these being multiplied and divided together is a positive. So I know to the left, or to the right again, sorry, I've got that type of graph. Now, if I go to -6, plug it into the numerator, I get a positive value. Plug it into the denominator, -6 plus 5 gives me a negative number. -6 minus 1 also gives me a negative number. But when I take and multiply two negatives, I get a positive, and divide a positive into a positive, I still get a positive. So at -6, I have a positive value, which means, again, this must go up. When I plug in a -8, you'll notice now the numerator goes negative. In the denominator, I also have two negatives. And two negatives multiply to a positive, but divide that into a negative, and I get a negative, which means this actually does cross. And here's the trick. End behavior says as I get very big negative, I must approach that horizontal asymptote. So there we have it. That one's a little more difficult. Let's move forward. Similar example to the last one, except this time you'll notice this denominator doesn't factor. So what's going to happen when I take my x-intercept? We'll notice when I set y equal to 0 and multiply by x plus 1, that whole term goes to 0, and I have 0 is equal to 5x. Therefore, x equals 0. The y-intercept, pretty easy. Set the x equal to 0, and y equals 0 for that as well. Vertical asymptotes, this is where it gets a little bit tricky. X squared plus 1 equals 0, so x squared equals negative 1. We know that's never going to happen. You can never square a number and get a negative. Therefore, no verticals. Horizontal, we notice the degree of our numerator is less than the degree of our denominator. Therefore, y equals 0. So let's sketch this graph out. I have one asymptote, and that asymptote's horizontal, and it's where y equals 0. So it's basically on that x-axis again. I have intercepts, both at 0, so that's at the origin. Once again, we have an intercept on our horizontal asymptote. And now I really, from here on out, don't know much about this function. So again, I'm going to have to pick a point to the left and to the right, to the left and right of 0. So I'm going to pick 1 and negative 1. And I'm going to plug it into my original function. When I plug in 1, I get a positive in my numerator. Denominator is positive. That equals a positive. So I'm above the axis in this case, but as I go to infinity, I must approach the horizontal asymptote. So it's got to come down. When I plug a negative in, numerator is negative, denominator is still positive. This gets me a negative value. So I drop below the axis, but again, as I go to negative infinity, I have to approach the horizontal asymptote. So my graph looks something like this. It's kind of a unique graph. Let's do one more before we get some questions going. This one's the killer. Now, in all these graphs, we want to take and make life as simple as possible. So we want to take, and I like personally to factor everything from the get-go. So I pull a 3 out. I'm left with x squared minus x minus 12. And I know that factors, so I'm just going to keep going. So that's 3 x minus 4 x plus 3 over x plus 2 and x minus 1. And this is where we're going to start from. I have an x-intercept. Again, we're setting y equal to 0. When y equals 0, I multiply the denominator to the other side, leaving with just the numerator. So I have 0 equals 3 x plus 5 and x minus 4. Therefore, I have two x-intercepts of 4 and negative 5. My y-intercept, once again, we'll take and set the x is equal to 0. That gives me a positive 18, I believe. My vertical asymptotes, I set the denominator equal to 0. Notice, if my denominator is equal to 0, I get negative 2 and 1 as vertical asymptotes. And for my horizontal, all I really need to do is look at the degrees. They happen to match. Therefore, I use the leading coefficients and divide those. 3 divided by 1 is 3. So we're going to come up here. Now, once again, vertical asymptotes, -2. Put that dotted line here. 1. Dotted line here. Horizontal asymptote at 3. Something of that nature. Next, I'm going to take and start plotting intercepts. I have one at 4. I have one at -5. And I have another one way the heck up here at 18. And from here, I think I can graph the whole function. Notice, I must go through this point, and I must approach this horizontal asymptote and this vertical asymptote. So this has got to go down. I think this is going to be the easiest problem we've done other than the factoring. The same is true of this side. I must go through this intercept and approach that part of the function and approach that part of the function. Now, up here, I must go through this point, and I can't cross this axis down here because there's no x-intercepts. So, graph's got to look something like that. All right, there's a lot to chew on in this. Hopefully you got some questions, and tomorrow we'll try to clear them up. I will give you these questions to answer, and do your best at this, and we'll go tomorrow. All right.